Hi, I'm Yonglin, part of the Ashton Graybill Spatial Orientation Lab at Brandeis University, and this is a project of Vivekananda and Vimal. When landing on Mars or the Moon, gravitational cues will be different than on Earth, and astronauts will be susceptible to spatial disorientation, which means that they will lose sense of where the upright is, and that could lead to crashes. Even on Earth, the leading cause of crashes in military pilots is spatial disorientation, so it's a really big problem. Well, what countermeasures can be used to address it? No one to our knowledge has used deep learning to predict the occurrence of crashes in a novel spaceflight analog condition as we have. So we collected data by having participants stabilize themselves in an orientation where they could not use gravitational cues, and as a result, they became spatially disoriented. The machine was programmed with inverted pendulum dynamics, and when participants tilted beyond 60 degrees, they would hit crash boundaries, after which the machine would stop and reset. Our goal was to predict the occurrence of crashes before they happened. To predict the crashes, we tested several different types of deep learning models, which are essentially neural networks. We found that stacked GRU was the best model for application. We trained the model to take segments of data from the disoriented participants and had it predict whether they would crash or not after a certain duration of time. We were able to predict crashes 800 milliseconds in advance, accurately with an AUC value of 99%. We found that how far in advance we could predict was limited because participants would make unexpected destabilizing joystick deflections because they were disoriented, which would rapidly lead to a crash. If our model could work in real time, we estimated that immediate corrections would prevent 80% of all crashes. However, this will require a faster reaction time than humans are capable of, which suggests a solution of AI taking temporary control of the spacecraft. Space exploration will often demand astronauts to solve novel problems that do not have known solutions yet. They will have to work independently because of factors such as time delays in communication with Earth. One way to help is to create an adaptable general AI. In our approach, the deep learning algorithm did not have any prior knowledge of the paradigm, such as inverted pendulum dynamics and the human vestibular system, and was not trained on optimal behavior. Instead, our model was trained on real, messy human data from our disorienting spaceflight analog task, similar to what astronauts would actually face in space. So because our model was successful, it suggests that this methodology could be applied to other novel and disorienting conditions as well, such as drifting during brownout or a loss of control in human postural balancing, in artificial gravity, or from vestibular deficits. So check out our recent publication on this, and great thanks to Trish for all of the funding and help.